This short program is presented for the purpose of introducing the viewer to revolutionary gold and precious gemstone recovery equipment. Gemstones in this instance are limited to diamond, ruby, and sapphire. In this day and age, when major gold-producing companies are closing down gold mining operations all over the world because they cannot produce gold at a profit, one company has developed the unique ability to produce gold at less than $100 per ounce and precious gemstones for less than 50 cents per carat using equipment like that featured in this short video. Placer mining for gold has been practiced throughout the world since before recorded time, yet today, placer mining for gold is not practiced by any major gold producer. The following sequences will follow the flow sheet of the Richfield gold recovery process in a gold mining operation at a mine site in Montana. The gold-bearing material is mined from alluvial deposits by any of several digging machines, then delivered to the feed hopper of the Richfield equipment as illustrated here. These sequences were taped in mid-November when the temperature was well below freezing. Due to slick road conditions, the feedstock was delivered to the 100-ton feed hopper by front-end loader rather than by 65-ton haul trucks, normally used to feed the plant. In many placer operations, conveyor belts are used to deliver the gold or gemstone-bearing materials to the wash plant. In long, narrow canyons, such as the location featured here, mobile, earth-moving equipment such as haul trucks are required. The gold-bearing material is fed from the feed hopper by specially designed variable speed feeder equipment onto an over high-frequency wet grizzly device where the cleaning and scrubbing stage of the operation begins. The finer divisions of the feedstock pass through the grizzly bars into the rotary scrubber machine below, while the larger components pass over the grizzly surface where they are exposed to intense vibrations generated by the specially designed machine and to water jets spraying water over the rocks and boulders as a cleaning, rinsing agent in order to continually flush the surface and surface concavities of every rock and boulder exposed to the grizzly environment. The -6-inch feedstock reports to the rotary scrubber, seen here. The scrubber was designed to scrub and clean everything presented to it at the rate of 200 tons per hour. The machine is equipped with high-pressure water jets that assist in the scrubbing and single-particle suspension of all of the contained solids passing through the equipment. The scrubbing and preliminary classification stages of the operation are achieved in this unique machine. After the scrubbing and preliminary classification stages are complete, the individual products are delivered to specially designed equipment for the separation and extraction of the contained gold and or gemstones. As seen here, the finer divisions of the feedstock are passed over equipment capable of classifying and concentrating gold and precious gemstones at the concentration ratio of 500,000 to 1. The steps required to achieve these startling results involves the use of specially designed high-frequency screens capable of dividing -1/4-inch feedstock into as many as 20 different classifications. The term classification used to define the act of separating the gold-bearing material into individual sizes such as 1/4-inch, 1/8 inch, 16th inch, 1/32 inch, 1/64 of an inch, and so forth. The equipment featured here divides the product into classification measured in microns. The high-frequency action of the screens prevent blinding or plugging of the individual screen apertures. Each of the individual channels shown in these sequences processes its own unique particle size classification delivered by the classifiers. The gold and gemstone recovery rate of the Richfield equipment often exceeds 99%. The total amount of material extracted or otherwise removed by the Richfield equipment from the feedstock is less than 1/10,000th of 1%, or only 2 parts per million. The induced sonic concentrators seen here employ unique riffles, where the gold particle is trapped as it passes over the riffle surface. The surface of each concentrator functions as a fixed frequency oscillator, resulting in a constant vibration of the riffle bed. Oscillations are generated mechanically and tend to maintain an active bed at all times for the collection of the heavier gold particles as they are exposed to the individual riffles. The 4 streams illustrated here demonstrate the method of delivery of the individual product streams from the classifier to the individual concentrator trays. The tailings or waste material from the individual channels seen in this tape are delivered as a slurry to dewatering equipment, where the water goes one way in the environmentally friendly process, while the tailings, composed of the sands and gravels and cobbles and boulders, report to individual hoppers for delivery back to the pit where the reclamation stage of the process is achieved. The facility seen here was designed to allow visitors access to each of the individual equipment components of the wash plant without hampering the operation of the equipment or endangering the visitor. The pond system seen in these sequences provides for the continuous recirculation of the wash water. The long, narrow pond seen here on the right is known as the sedimentation pond and is designed to settle out and remove more than 95% of the suspended solids from the wash water, while the balance of the water reports through the recirculation culvert seen at the extreme end of the pond, where the water is delivered through the recirculation pond on the left. The larger pond contains in excess of 1 million gallons of water. While the gold extraction process uses between 3,000 and 4,000 gallons of water per minute in the washing process, it takes more than 5 hours of continuous operation to recirculate the pond contents one time. Nearly 90% of the water used in each cycle reports back to the recirculation pond system for reintroduction to the process. The wash plant components are constructed to allow the material to flow from the highest point where the gold-bearing material is dumped, then down through the system to the tailings disposal and wash water recirculation system. The nugget trap equipment is unique to the Richfield gold recovery process. The gold nuggets seen here are typical of the nuggets extracted from the Washington Gulch deposit. Nuggets of up to 5 ounces in weight have been recovered in the featured nugget trap. It is important to note at this time that the mining operation featured here is for gold only. Many of the gold recovery equipment components also apply to precious gemstone recovery operations. Again, ruby, sapphire, and diamond. After the gold recovery system has been shut down, cleanup of the various concentrator channels is achieved by simply tipping the specially designed recovery trays up and by washing the gold and other heavy concentrates trapped in the riffles into the built-in receiving tray below. After the riffles have been cleaned, the concentrate is washed into secure containers attached to the end of the individual trays. The gold nugget concentrations seen here have been collected in their respective concentrating trays. It is important to understand that each one of the individual trays treats only its own properly sized feedstock. By using this technology, however complex, different elements can be efficiently separated in accordance with the specific gravity of the individual element. On this occasion, approximately 25 ounces of gold was recovered from the material fed into the system. The gold concentrate captured in each of the individual trays is composed of gold particles that are basically the same size and weight. Other heavy elements can be seen here. They include particles of magnetite and hematite, representing elements of the iron family, as well as other